Hello everyone. Welcome at the Amsterdam Ruby Meetup of this November. I was hoping to see more of you in this room, but potentially we'll see you at home. Mark is there, so for everyone in this room. So we're experimenting still with live streaming this event. This time you can even rewatch the show when you're home. Yeah. And so you can ask your mom to give you feedback on your presentation. Hi, Mom. It's going to be fun. Anyway, forgot my clicker. So we have a code of conduct that we adhere to. That means all speakers, presenters, guests, people watching the live stream, commenting on our whatever. So if you don't know what it is, read it. Because, well, you're here, so you adhere. Yes. Also, a big shout out to Silverline for not only feeding us, but also for having us here. And you can be sure that I will say a thing or two later. Anyway, we have two talks lined up. Potentially, Tinco Andringa starts at 7:10, which is in 2 minutes. I asked him, is it enough if I just introduce you as it's about DDD? And he said, well, maybe make it DDD versus Ruby. So clearly this is going to be something that can be against Ruby or something. I don't know. And then after the break, we have Alejandro talking about, well, storing things in Kafka. It's going to be interesting. Then I'd like to give a shout out to Silverline.
Thank you.
Introduce your company.
Yes, so I can talk 15 minutes, I heard, but I won't do that. Hi, everybody at home. I'm going to stand here. So we are Silverline. You might know us from either Scrum trainings or Yacht, online accounting system. That's what we built. Or maybe Domotica. We built Tinco. It's a bridge between the home automation world like Z-Wave or KNX and your Google Home, Apple HomeKit, or Amazon Alexa. And we, as many other companies, are looking for new and cool developers. So if you're interested in working Fridays for yourself as learning or working on cool projects, home automation or fintech, please come to me afterwards and enjoy the evening.
Thank you. You're welcome. Also, we have a meetup coming up in, I think, December 17th. I'm not completely sure. If it's a Tuesday, I guess it will be the 17th. Is it 17th? We think so. Took already 5 minutes to figure out if it's the 17th. Fantastic, hilarious. So we have two speakers lined up. Noah Berman, he will talk about the Hippocratic license. And Peter Lange, which was described as how to make your ops people happier, live long and prosper. And well, it sounds like one big love story for engineers on, well, not fooling around with your ops. Anyway, we're still looking for a nice location that is at least Wi-Fi friendly for the people at home, so everyone can follow it. So this is the moment that you think, oh, we're hiring. We want to have all those Ruby devs in our house, yeah? So please contact me or Floor or Tom because they're organizers, just like I am. Anyway, hope to see you there. And this one's really nice. I'd like to invite, in a minute, Tinco to the stage because I had that urge to know more about DDD and I was thinking of people that could present this thing. So this is just me abusing the Amsterdam Ruby Meetup group to just learn a thing or two about DDD. Thank you, Tinco.
Super. Good. All right. Hi, everyone. I'm Tinco. You've probably never heard of me. I used to work at Fusion. Maybe you've heard of that company. We built Fusion Passenger, which is a web application server that many people might have used. After Fusion, I've been a freelancer for a while and did a couple projects. And I also taught at the Wagon the demo weeks, really cool. Maybe if you can visit the demo day of Laguna one time, because they're cool kids or whatever, making cool projects. And after that, I did a freelance project to build an MVP for Aeroscan. Aeroscan are people that fly around with drones taking pictures of your house. Maybe if you live in a social housing building. So we're flying drones for social housing corporations to enable building inspectors to know what the condition of your building is, so they can save money, save time, and just be aware of your state of your building, so the next time you step out of your door, the balcony doesn't fall off. Stuff like that. So Arno and Floor asked me to talk about DDD. I thought, oh, isn't that a little bit ancient? But then the underlying sort of idea is, well, DDD is a thing that lets you think about other architectures than just having an MVC, building a CRUD app. It gives you more structure in figuring out and doing your domain analysis. And also it leads to interesting architectures. So who here ever started a project from scratch? A new project? Almost all of you. So the next question was going to be, who here ever built a feature from scratch, like a new feature? Probably everyone then, right? Almost, yeah, no only maintaining stuff, right? So who here knows what domain analysis is? Sort of, no one. Okay, so that's super interesting. Okay, so I assumed actually that everyone knew what domain analysis was. And maybe this is because I went to university and they teach it here, but domain analysis is actually the first thing you do when someone asks you or you decide to make a new project. Domain analysis is just maybe a fancy way of saying, I'm going to think about my problem, right? I'm going to think about the domain. And the word domain means everything that happens around the problem you're going to solve. So if you're building, I don't know, booking.com, then in your domain, you've got hotels, you've got visitors, you've got dates, you've got like all these words that have to do with hotels, and the word booking, right? It's also part of the domain. So the first step when solving a problem is doing a domain analysis. What's going on, right? And then from that domain analysis, you might decide on a certain, like maybe a database design, right? Maybe interaction design, like how are users going to interact with the thing that I'm building that's going to solve their problem. All of these things come into play during domain analysis. And DDD basically is a bunch of words and a methodology to structure domain analysis and to arrive at certain architectures that fit your problem domain very well. And then I have to say, I've never actually practiced DDD, right? So I was asked to do this, and I've never really done it. So I have to disappoint you that I'm probably not the best teacher in DDD. Maybe you've got to talk to the Silverline guys who actually practice DDD as part of their consultancy model. Or at least their business model, making good solutions for their clients. But what I want to take from it is someone who's done a lot of domain analysis, reading about DDD, figure out what's nice about it, what interesting concepts arise from DDD. So these words, they're like the key components of DDD. They're the context, like what's going on, and domain has like that's the concrete thing. But the most interesting thing to me is the ubiquitous language, right? So this is a problem all developers come into contact with. You have a class called player in your game, and then you have to model that on the front end, you have to model that on the back end, maybe you have to model that in the business logic, and there's all these sort of places where some word might mean a slightly different thing, and a part of your domain analysis can be and is advised to be in DDD, to have a ubiquitous language that says these words mean certain things. Maybe these words mean certain things in certain contexts or certain, and so you can set boundaries to say, well, when we're talking about the backend and we're talking about a player, this is what we mean. This is the context where this language is viable, and this allows teams to communicate with each other while working on a larger project. So the bounded context, that's a super interesting part, is that when you have that player class, what does it mean in front end? What does it mean somewhere else? But also it allows you to just not worry about naming conflicts, because your contexts are bounded. Everything that you say within a certain aspect of your program, it doesn't influence other parts. And I'm going to get to a more sort of concrete way of showing this, but for now, I hope this comes a little bit across, that you can really think about the language you use to describe your problem and your app, and how that can influence your architecture, but also influence the communication between software teams and make it easier to come to a cool architecture. Right, so and then in DDD, there's all these sort of standard concepts that arise when making a new architecture. And many of these might be familiar to you. Actually, if you never heard of DDD, as I did before I prepared for this talk, well, I heard about it, but I never applied it, right? Then you still have heard of most of these things, right? An entity is a single thing in your app that interacts with other things, right? Value objects just hold a little bit of data. You've got aggregates, domain events, just things happening. Services, repositories is where you put your data. Factories to make new objects. These are sort of general things. They happen in all software development. They don't specifically have to do anything with DDD, but in DDD they're getting nice definitions, and they're like integrated in coming to an architecture. So one thing that's very closely related, well, sort of almost evoked, if you think about DDD, is CQRS. So CQRS is actually a very simple thing. It's talked about a lot, and it's a simple concept, but it has very heavy consequences for the architecture of your app. So the idea, one thing that arises from DDD a lot is this idea that you think about events happening in your app, and events being triggered by things in your app. And a nice way of dealing with that sort of thing, with the problem of having events, is by applying CQRS. So what is CQRS? It stands for Command Query Responsibility Separation. Yeah. So you have your commands and you have your queries, and they have different responsibilities. So they should be separated, right? There should be a separate thing that accepts commands, and there should be a separate thing that gives the user data or just interacts with defining things. And if you have these things separated, then you can do very nice things. Like maybe you have something that is very good at writing data, accepting new data, right? You can make a database that's specifically designed for accepting new things. And accepting new things might happen less frequently than just telling people, showing people data, right? So you can accept commands, and you have a database specialized for that. And maybe you have 10. Maybe you have a Postgres database, right? And that accepts writes. And Postgres is notorious for not scaling horizontally, right? You can make it scale horizontally, but it's a little bit difficult. But what if you have one Postgres master and all it does is accept writes, and then you have a bunch of Postgres nodes that just serve reads, right? So you can separate these two things, and then you have one server's service that just writes to one master node for secure for your data, and then you have multiple Postgres instances that just serve the data that has been written by the command section, and you have these things separated, and this, yeah, makes it really nice to achieve these things. So what does that mean in practice? Practicality of it is that we have a bunch of complexity, right? If we have one or a couple writing Postgres databases, we have separate reading Postgres databases, that makes your app more complex. If you make a standard Ruby on Rails website, Ruby on Rails application, then there's only one database, and things go in, things go out, and it's all simple. But then you go to the scale of Twitter or to whatever sort of scale, and suddenly that doesn't make sense anymore. If then just a couple hundred people are writing tweets, but then a couple billion people are reading tweets, does it really make sense that they're interacting at the same point, right? And if you think about performance optimization and stuff like that, then it doesn't really make sense anymore. And then you get into complexity. It has to be more complex than a Rails application. So this is where DDD meets CQRS, because you sort of think about the problems you have in your domain, and then you arrive at new sort of architectures that match that. And you also throw away the conventional way of thinking about your app. Who here has only made Ruby on Rails applications when using Ruby? So it's like Ruby on Rails projects, or that's the only projects you've worked on? Okay, so only a couple. Who here has made command line applications using Ruby? Slightly more. Who here made just web services using Ruby that use no framework at all? Couple, right? Who here uses different framework than Ruby on Rails? Nice. Who here has should I say how many of you raised their hands, or do you sort of, are you aware of what's going on? Yeah, okay, so there's like slightly more than half that use offer. Okay, so, okay, cool. Okay, so what I'm gonna do now is sort of think about, or like build a little project. I built a little project in the past couple of days that just moved away from Ruby on Rails and made a solution to a simple problem where I applied the concepts of making your app fully from a domain analysis without looking at existing frameworks and just connecting the things, right? So first I got this. Did I just, there goes my water. What I want to do is implement the game. Whoever played the game Go, the board game Go? Has anyone played that before? Okay, a couple. Who here heard of the board game Go? Yeah. So it's like a strategic and tactical board game that's a little bit like chess in Europe. It is in East Asia. They usually play this game in China and in Japan. It's a really popular game, and the nice thing about Go is that it only has one sort of piece you put on a board, but it has a bunch of rules that are quite simple, but they have very vast implications. So if I would build a Ruby on Rails application, how would I store my board game, and how would I process these moves on it? Right? This is a thing you have to think about. Maybe we use Active Record, and we'll put the full board state in the database, and that's sort of the wrong way. If you think in a DDD way, that's the wrong sort of way of approaching the problem. The way we would approach it, if we do work only from domain analysis, we just think, well, what's the business logic, right? What's our domain? How do we solve our problems? And how then do we achieve all of the things that we want to achieve without like starting at the real Ruby on Rails application? Right? Okay, so fun thing is that all of the rules of Go and all things, they're like a pure piece of bounded context, right? You can talk about Go and never talk about web applications. You can never talk about whether this is a game you play as a 3D game on your desktop or on your mobile phone, or you can say, well, someone is using SSH to go into a server and play Go over there. You can do it over command line interface, or you can do it on a website. You can do it in fully pure JavaScript. You can do it wherever. But all of those cases, the business logic stays the same. So, in theory, a gem could exist that implements the full game of Ruby, right? You could make all of the business logic one gem, and then just solve all the other problems in other aspects. So that's actually what I found, is that I'm just going to build a little app, and it's going to use WebSockets, it's going to use message passing, and it's doing a little bit like a CQRS. It's close to being just fully CQRS app that implements playing Go online with someone else live. So let's see. I have to sit over here, excuse me, because we don't have a little table. So let's see, what we'll look at first. Let's go to the command handler. So our first concern is...
Can everyone see it in a bit more?
Oh. Should I make it a little bit bigger?
Yes.
Is this large enough? Is there someone who cannot read this? Okay, so we want to build a little Go application, and we're going to play this game of Go, right? And our first concern is that users want to make moves, right? They're going to send those moves, and those moves, we want to apply business logic to them, and then maybe send it on, send the result of processing that business logic somewhere else. So we can start by making a module Ruby Go game server, and I'll put in a module command handler, and the command handler has to run, and it's going to take care of this process, just the process of accepting commands, executing some business logic, and then passing on the data to somewhere else. So it should be, so there's these three things we're doing, so there should be 3 lines. Oh, there's 1 line more, but could have done it on 3 lines. We're going to accept these moves over just the regular web requests, right? It could be anything. I could replace this line with any line, but accepting them as HTTP requests, right? And then what do we do with those HTTP requests? We pass them on to a game controller, something that controls the business logic of the game. And what does the game controller do when it's done processing its business logic? Well, it's going to pass that data on to somewhere else. So that's the broadcaster, right? So we have an HTTP listener that has a controller that is going to send things, and we have a game controller that's going to process business logic and send it on to a broadcaster, and then the broadcaster is going to save the data somewhere, right? And from this architecture, we've not said anything about how the Go game goes, right? And if you look at the HTTP listener, it's just a class that has a run method, and in the run method, we start a new thread, and we start a web server in that thread, and that web server is going to handle something, right? And these are the things it can handle. It handles a GET request. It's a hi. It's a self-documenting API, right? Because it says hi, post moves to game.emo with params x, y, and color. So this is how we can make a move on our Go board. And this is the post request you can make, right? You get the X and the Y. So this is the location where you put your piece on the board. And then we say, well, we'll send the color because you're either black or you're white in this game. So we get the color, and then maybe a game ID. And then we send it on to the controller to handle this command, the game controller. Yeah. Okay. So then we can move on to the game, to the broadcaster. This is the other side that also knows very little about the game itself. And it is just connected to a Kafka message queue. And whenever it receives the method send message with a topic and a message, it just puts it on the Kafka queue. And then finally, the game controller, this is where all our business logic would be. Maybe if we take a naive jab at making a Ruby on Rails application, right? You just put your business logic either in the model or in the controller. And ideally, your controller is as small as possible in a Rails application. Well, here's the same sort of thing. The only code we put in here is connecting the three systems that we have, listening for the HTTP requests, and then doing some business logic, and then sending it on. Right? So I found this gem called Ruby Go, and it is a command line Go game. So you just start it on your terminal and can play Go against yourself. Just put moves and see what happens, or maybe load a Go game that someone else has played in and see what's going on. And I did no modifications of this gem at all. I just found it on the internet, typed require Go, and now I'm going to use it as the engine, the business logic, to my game. Right? So I initialize it. I say I save the broadcaster. I have my game. Make a new Ruby Go game. I'm doing at board size 9, which is for people who don't want to play very long games. Normally you play at 21, which is a super large board. And then just when we're initializing, we're sending the first message that we have a new state, and that is a new game state. And this controller, it's gonna get commands from the HTTP listener, right? The little web server that's listening for incoming moves. It's gonna look at the command type and the attributes, and when it's a move, it's gonna handle a move command. And handling a move command means looking at the color. If it's white, then it's white, and else it's black. And then it will send that move on to the game object, which is just this gem that I included. I changed nothing about. I just checked if the test suite ran, and it ran, so it works. And I just sent, well, we're going to make a move in this little gem. And then when that's done, when the game gem has processed this, I'm just going to send a message that, I'm going to send two messages actually. One is that if this was successful, we're sending this move has been made to the moves channel. This is not really relevant, but this one is more relevant. It says, when the game has a new state, we're going to send an update to wherever, it doesn't matter what, whatever is going to listen to new game states, new state of the board. So if our player makes a move that is valid and it's going to make a new stone on the board, then this state will be updated with, and all other people that are playing this game or looking at this game will get a message. We have a new board game, and this is what it looks like, right? And people who are listening to this stream, they'll just say, this user has made a move. And they'll look at that and say, okay, that player made a move. Sure. And that's it. This is just formatting of what a state looks like. So it has a board and it has captures, black and white, which board pieces have been captured. This is a little bit of logic. So this is what the game looks like. So this is the game controller. It has very little code pertaining to the game, to the business logic itself, and it's all just connecting stuff. So now this is already everything. This is the full backend for a service that's let you play Go games online. Right? This just lets you make moves. And then the other side is the query side, which is, listen, when I make a move, I actually want to know whether the move I made was valid and what the other user is going to, how it's going to respond, right? So that's me asking about the state of the game. Well, we have the same sort of thing. So we have a query handler, and it has a, it's going to listen on WebSockets for incoming queries, right, on a WebSocket. And if someone connects, it's going to update that user with the state of the game. And it's going to receive state of the game from the message queue. Right? So whenever a new message comes in with a new state of the game, it's going to broadcast that new state to all of the connected clients. So it's just these two components that it has. It has a WebSocket listener and it has a message queue listener. And that message queue listener is connected to the WebSocket listener. So whenever a message comes in, it has something it can send that message onto. So let's look at the message queue listener first, because that's not relevant to Go at all. It's just, it has a run method, and it just it has a Kafka client, and it just waits for messages, and then for each message, it's going to parse that message, right? This is a little bit of logic that's irrelevant to the game Go. It's just specific to the way we implement the service. Parsing JSON, reading WebSockets, these are all a separate responsibility than playing the actual game, right? So we parse the message, and then we have our message handler, which was passed in. And then on that, we call receive message. Like, we've got a new message, you can do with it as you please. So that's all the boilerplate for implementing that. And then the WebSockets listener, it's sort of the same. It also has no business logic at all, right? It just gets moves and then passes it on to the WebSockets listeners. It's just a piece of middleware. So when you call it run on this, it keeps track of all the connections. It starts a WebSocket connection, and the WebSocket handler says that whenever a new client comes in, so this is a bit of a complicated line, it looks like, but this just starts a WebSockets server, yeah? And you give it a do block, and the do block gets a new connection. So whenever someone connects, this do block is going to run, and as a context, it gets a connection object. The connection object you can call write on it to send a message to that person, to that client that just connected, or you can read from it to receive a message over the WebSocket. Yeah. So we're just going to store this connection in a table of connections. We can use that connection later to send messages to. For now, we're just going to save it. We're going to write the current state to that connecting party. So whatever the state of the game currently is, we send that to the person that just connected. Because if they just connected, they don't know what phase the game is in, right? And then with this client, you have to call flush after every message. So we call flush. And then there's just a while loop that just reads forever on this connection. So this thread, its responsibility is to just wait for incoming messages and do nothing with them. Yeah, so we might, if we made an interactive sort of system, we might do something with the messages. But for now, this is just reading, doing nothing. Yeah. So if you have maybe multiple kinds of queries that you want to do, then maybe you can do some more event handling here. But we just listen to the event that the user connected. And then whenever a message comes in, this method is called receive message. Yeah. So whenever a message comes in from our message queue, so that's been handled by the business logic, then this method gets called, and it's just going to set the state to be that message, right? Because we're getting states back in. every time someone makes a move, we get a new state over our message queue. So we're going to save that last message as our current state. Right? Kafka might guarantee that that's the last state for us. I don't know if I figured it that way, but it might. And then we're going to broadcast that state to all of our connected WebSockets clients. Over here. And the broadcast is just is connections of each. So connections that we save, for each of them, we're going to write this message, the message that we're broadcasting to that client. And then we're going to flush. Okay, so that's all of the query handler. And then we just start these two. So we have an active folder here. It says Ruby Go Game Server run command handler. And we have Ruby Go Game Server run query handler. We have two binaries that we run. We could have them both in separate Docker containers, maybe. We can scale them, maybe independent from each other. Now I've already ran them here in the terminal. There's an exception there, but that's, I think, because I disconnected something. So I made a tiny little front end for it. So there's an index.html at the root of the project. And here's the game. And we can select a color like black and put a star there, and it appears. So remember that sending a command to the database didn't immediately respond with a result. So if I send a command to there, the HTTP listener, all it's going to do is run the business logic on it and then put the new state on the message queue. It's not going to send anything back to this front end. So what I'm seeing here, this black box that I selected, that's actually the query handler getting a new event that something has happened and there's a new state. So let's play a little game here. Say white moves here, black moves here, and then black moves here. And then you see that the logic made this white thing disappear. And we've not worried about that at all. So maybe I, as a programmer, got the assignment from my boss to write just the aspect of this app that connects all of this together. And some other programmer on my team got the assignment to make a fully functional Go implementation, right? And now we haven't even talked to each other. The only thing is I read his documentation and I just wrapped my architecture around it. So, and we can connect to this in a different tab. And you can see the state of the game here. So maybe I have white here, that moves there. And then you can see on this other tab that this move was indeed made. And everything sort of works. Should I show the front end, just to prove that nothing fishy is going on there? Okay. So, next. So it's just simple Ruby Go game, some styling to make it look super pretty, right? And then there's some JavaScript. We've got the query prefix. So this is localhost 9294. This is our query server. It's a WebSocket location, and then the command server is a regular HTTP server running on localhost. This is port. And there's an initialize method, and the initialize function, it makes a new WebSocket connection to the query prefix, and then whenever a message comes in on that, we're going to update the game, parsing data that we got in there. Updating the game. Console logs, because I was debugging, of course. And then all it does right now is populating the GoBan, the board. And the board is just, whenever I get a new board, I'm going to find the GoBan element, and I will make a new content string. And then for each row in the board, we add a TR. And then for each column in that row, we're going to make a TD. This right here. Actually, I see a bug. Let me just Does my keyboard not work? Yeah. Wow. Okay, I cannot look at the screen and type at the same time, apparently. Right? I had a bug in my HTML generation here. Anyway, worked. Crazy browsers, right? And then I just set the inner HTML of my of this element to be this new table. So anytime a new game state comes in, I just rewrite the HTML of our goal board. Did I just do something weird? Yeah. Okay. Anyway, so you see here that each of these cells, it has an on-click, and that on-click is select position J and I. So select position is over here, and it says do a fetch request to command prefix /game ID /move, put in the X and the Y and the color, and it's a method post. And that's it. That's the entire thing. There's something that sets the color. We're not handling the response of this fetch, right? That's all that makes it CQRS basically, because we're not dealing with response to these queries. We're just sending commands and then doing queries from somewhere else. And this is a really simple sort of almost what's it called, like a pathetic case or something, because it's not really necessary here. Because this is a board game, you make moves. Of course, the response to each move is going to be the new state of the board, right? So this would work perfectly in a Ruby on Rails situation. But maybe instead of a Go game, I'm making a real-time game where the user has their mouse location that's streamed, and then that has some effect on the server, and it gets a real-time stream of how other people are reacting to that mouse cursor moving, right? So these two are completely separate, and that can be the reason for CQRS. Okay, let's go here. Oh, did I close this? Yeah. Okay, so that's basically my talk. So I just showed code to inspire you to maybe think about your architecture and think about how you can build something without using Rails. Maybe apply this sort of thing like a message queue or separating your architecture into a command section and a query section. And maybe inspire you to think about domain analysis a little bit, and maybe read the book about DDD, or talk to the Silverline guys on how you actually make a full-on way of dealing with customers that have new sort of ideas and new problems to solve using DDD. Yeah, that's sort of it. I already talked a little bit about the company I'm working for now. Is Aeroscan. We fly around with drones, take a bunch of pictures of a building, like 2,000 pictures. We fly around with a 60,000 euro drone, and on that 60,000 euro drone is a 40,000 euro camera. Yeah, it takes 100 megapixel camera. So this camera, it normally hangs on the bottom side of a plane that flies maybe a couple kilometers in the sky to make pictures of terrain, right? But we take it down and we hang it on this drone that just flies 10 meters from a building. So we get these crazy large pictures of these buildings, and then we take 2,000 of those, and they're about 100 megabytes per piece and per picture, and we turn that into a photogrammetric model, which means a 3D model based on photos, right? And this is not something I wrote. It's a software that we bought, so it's a little black box. So we take photos, put them in this black box, and then we wait a week, and at the end of the week, a 3D model comes out. And then, so I built a Rails application, or just a Ruby application that our operational teams can upload these pictures to, put Google Cloud Storage. First, before we do that, actually, we run a machine learning algorithm over the pictures to erase any people, because we do this for social housing corporations. So there's actual real people in these pictures that we have to guard their privacy. So we erase those faces and other identifying parts. We also remove like license plates of cars and stuff like that. and then within 48 hours, we delete everything that still had stuff on it, and it never goes to the internet. But then, when it's all anonymized, we put it on Google Cloud Storage, and then it gets fed into this photometric system, and then we get a 3D model. And then there's a Rails application that we built that allows the user to browse through this 3D model in the browser and zoom in to an insane level. So our clients or our users are actually building inspectors. So there's this NEM standard that they have to comply with. And they say, I want to be able to look at the grain in the mortar that's between the bricks. If those grains, if they're like nice and even, then the mortar is still okay. But if there's little cracks in it, it means the mortar is not okay anymore. And the owner of the building has to do this super expensive operation of removing all the mortar and then putting in new mortar. And this tens of thousands of euros. So they want to know if they have to do it or not, right? And now they can use our app, or the inspector can just stay at home. We have an inspector that works in Dokkum, and he's working on a project that's in Rotterdam, right? He doesn't have to go all the way to Rotterdam. He can sit it behind his desk and look at the mortar between the bricks. And if it's all right, he can say, don't spend 100,000 euros redoing this apartment complex. And everyone's happy, sort of. Yeah, so we do anonymizing, we do processing of the data. We have this digital inspection process that's all built in Vue.js and in Cesium.js, which is a 3D engine that's really suited to these geospatial systems. And we don't have interactive deep learning yet, but we have machine learning on the anonymization, and we're actually training a AI system or machine learning system to automatically detect whether the mortar between the bricks is okay. But of course, we need input for that. So right now, there's people just clicking around and making annotations, but we hope that in the future, we take all these annotations, train an AI, and then hopefully it does it for us. So this is Aeroscan. If you want to work for a cool company like mine, come work for me. I hope you enjoyed this talk. Thank you very much.
I don't know, do you have a space in Amsterdam?
Yeah.
Then
Oh,
yeah.
yeah. Yeah. So we have an office in Amsterdam and we have an office in Leeuwarden.
I mean, you took the sponsor slot already, so might as well.
Feel free to just be seated, or feel free to have a break, mingle, and talk to some people that you've never talked to, because the next talk will start at 8-ish. I would say.
What? Like 4 minutes?
Yes, I would say 10 minutes past 8. Also for the viewers at home, 10 minutes past 8. So you have 15 minutes to get a beer. You have 15 minutes to get a beer. So. There we go again. Yes, there we go again. Nice to see all y'all here again. Just by counting heads, I think no one left. Fantastic.
Like, it's an accomplishment. Celebrate those things. Like, this is
I have been standing in this position after the break that I thought, oh, why is everyone gone? Especially if your own talk is already, well, performed. Anyway, I'd like to hear a big applause for Alejandro for talking on streaming.
Yeah, right. So thank you very much for coming. Also, thank you for the organizers. We lured you with this talk. Like, the name was pretty different to what you heard before. It was like storage with Kafka, which is really not. It's actually an experiment. So, but if we say an experiment, no one comes. So, no, actually, this is how GitHub does it. I know you all believe that that's what you're going to learn, but actually, what you're going to learn is really what I'm playing with in my work time nowadays. But anyways, my name is Alejandro. I work for GitHub, obviously. I've been at this company for 2.5 years almost, but definitely just as Tinco. You don't know my name. No one knows about me, and that's fine. But you do know the company, hopefully. And I work on a team called internal interfaces, and that's kind of whatever that tells you, right? Like internal interfaces. It's like everything that can be an interface, then we are supposed to be there, which is like really a lot of things. And at the end, we're like, sure, we can help you with that. Anyways, so the motivation behind this experiment with Kafka and event streaming is trying to solve a couple of problems that we have. And at this point, I think I'm just going to sit because it's a lot more convenient. So I'm going to guide you through those problems. So what are the problems that GitHub has? We have a lot of problems to solve. This is some of those that my team in particular, and when I say we, I also mean the application architecture team, which is kind of like, say, 5-6 engineers from GitHub, a few of them principal engineers, which is like the more senior engineers of the company, and they kind of came together about a year ago and sat down and, okay, this is a direction architecturally that we want to take GitHub in order to solve our problems. And those 3 are some of the problems we want to solve. And generally speaking, I think those are the big problems that companies at scale have. Well, at least the first one, for sure. Like any company working at scale will have the replication lag problem. And I will talk to you about that. We also, of course, all these problems are also to be fixed, worked with database infrastructure, everything you can imagine. The people working with Kubernetes and all that stuff. So these are very specific problems to kind of big companies. And in that, what I'm trying to say here is, what you see here, you don't necessarily want to have to apply it. Don't go to your company like, oh, now we should like put everything on Kafka. Just as much as you should not be doing microservices if you're like a 20 people company, right? Maybe it's not the best idea. I mean, if you want to do it, up to you, but I would suggest you don't. Anyways, so what's the first honestly the fundamental problem we face at GitHub? It's not a problem of services. It's not a problem of the monolith. GitHub is a Ruby on Rails monolith. It's a big one. But our main problem is actually replication lag. And replication lag means we have a really big database called MySQL1, a very creative name, and that's the one that has all the main tables that you can imagine at GitHub. So that would be users, repos, issues, pull requests, all the kind of the fundamentals of GitHub. That is in a single cluster. It's called MySQL1, and that thing has like just if you think about how Active Record works in terms of like cascading operations, if you have, imagine GitHub itself. So if you have an organization and that organization has a bunch of repos, and those repos have a bunch of issues, and those issues have a bunch of comments, and so on, as soon as you hit delete on an org, that cascades into a lot of operations really, really quickly. And that goes first to MySQL1. And then all the replicas that are catching up with all those operations, they gotta be like, oh, let's just go and get everything, all those changes that are coming. And then what you have is spikes of replication lag, meaning that some or all of those replicas are seconds behind the main one. And what this in like practical purposes mean is, if I go and create a pull request or an issue and there is replication lag, I get a link that I can send to my colleague via Slack, and my colleague clicks it, and he goes into a replica that is lagging behind, and he gets a 404. Like, but the issue was created. Why am I getting a 404? This makes no sense. And it's just because there is replication lag. Obviously, this is a case that you would rarely encounter. We take measurements against that. We don't want that to happen. It rarely happens. But it's definitely a challenge. And this is especially a challenge for systems that are using that URL. So you have webhooks and all that. So when a new pull request is created, a bunch of systems are notified about a new pull request, and all of them are going to that link to do something they got to do with it. And they're finding 404s. I'm like, oh my God, but didn't you just tell me that these things exists? And that's a big problem for us. That's kind of when things are scaling, that's one of the main problems that you will face. There are many ways to solve that problem. And I will talk to you a little bit about that later. The other problem that we have is, one of the ways we want to tackle it is siloing. meaning we have some big clients, say, for example, Shopify is one of our biggest clients. And if Shopify does a lot of things with GitHub, they are really, really heavy user. And that means when if they trigger heavy operations in their own GitHub account, that can affect a bunch of accounts, a bunch of other accounts, like all of you potentially. So what we want to do is minimize that risk by siloing people. And siloing big companies, but also just clustering a bunch of companies into a set of servers. And what you see here is kind of the full stack of GitHub. You will see GitHub is composed of like the Rails monorepo, but also other pieces like the servers where the Git repositories are. So that's also an important part of the problem that we want to fix. And then eventually, what we want to get into the future is to solve that replication problem. We want to have sharding. We want to do sharding. Sharding means taking a table that is really big, like you can imagine. For example, the pull request table is gigantic at this point, and we want to break it up into a bunch of hosts. Right now, we cannot do that. That thing is in a single computer. Of course, it's replicated, but it's essentially speaking in a single computer. We want to be able to break that table into like, okay, let's say pull requests from 0 to 100 in one, or 1,000 go into this computer. The other ones go into the next one. And you keep chunking it in pieces that are easy to manage. Easier to manage, but that comes with a bunch of other problems. How do you find a repo among all those hosts if you don't know what it is exactly? So sharding is like a really good solution for in order to scale things, but it's really hard to implement. So ideally, you want to push sharding as much as you want until you have to do it, and then the day you have to do it, you deal with the problems that it comes with. So those are the problems that we are facing, and we're doing a lot of efforts around that. And Logbook is the project I'm working on, and my team is working on, and it's just an experiment, really. It's an experiment. It's something we have been trying to see where it takes us. If it's the right solution, maybe it is, maybe it's not. You might never heard of this anymore again. So that's what happens. You just try it and see if it's the right solution. So first, what is Kafka? This is not a talk about Kafka, but in simple terms, it's just a bunch of queues. So these topic things will be the queues. You have producers, and those producers you throw messages with the producers. You put messages into those topics. You can ignore this partition part for now. You put it there, and then a consumer is getting them, or a bunch of consumers or consumer groups are getting those messages and processing them. You have heard of those queues before, so this is not like a completely weird concept to all of you. Some of the cool things about Kafka is that it doesn't have a specific file format, so you don't have to have the messages being JSON or something. It can be whatever. It's just a bunch of bytes. But in our case, we use protocols. That's important. For something we will see later. And then it scales. And the reason why it scales is because that term you see there, partitions. And I don't want to talk too much about that, but essentially, Kafka rebalances. So before, if you have a queue, the entire queue is in a single host. What you can do with partitions is you can partition the queue into a bunch of hosts, and those are the partitions. So imagine that each one of those partitions is a different host, and so that's why it's kind of easier to scale. It does a lot of that heavy lifting for you. Okay, so what is the Logbook architecture? The thing we have been trying to do. So GitHub is the main repo. It's a Rails app. Users generate events. You can imagine any event. In this current experiment, the event we have been working on is one of the more core ones, but also kind of a simple use case. That is creating an issue. So you create an issue, and that generates an event. Then that event is stored into the topic A in Kafka. That's the first place it goes to. Then there are consumers that are going to process that thing. So they're going to get it from the queue, do the magic, and then store it into MySQL. So now what we were doing before, just as any regular Rails app, is going through Active Record. Now we still have Active Record, but that Active Record is now in an independent process. those consumers are independent from like the thread that is processing your request, going through that part, right? Like that we usually go with active record. Now it's being done by these other consumers, and then it's written to MySQL. And then the other bit that we want to achieve with this is we will put those messages after we have processed them, and then we say, okay, someone created an issue and it was successfully stored into our database. We can put it in the topic B part, or the other Kafka topic, and then other systems like Search, for example, Search can take that event from there instead of like going to the MySQL database, get it from there, and index the data. Or if we have a machine learning engine, then they can also get the data from there, and they don't have to be doing queries to MySQL. So we want to reduce the amount of queries we're doing to MySQL. That's always a good thing for us to do. And then there is this bit, the Redis notification system. That means when you create an event here, we have to, at this point, we kind of have a timeout. We set up I think it's BR pop on Redis. So your browser will be hanging there until we get a notification back from these consumers that your issue has been saved. And then we do our push, I think it is. And then that bpop is just waiting there until you put something on that list of whatever it is in Redis, and then the request will continue processing. And that's the way we kind of handle but that's not efficient at all. We will eventually, what we would have to do is create a proper notification system where we're just polling all the time and asking, okay, is this thing processed? Is this thing processed? And what you will actually see is something like this. The UI will change kind of to have a behavior where we're a lot more in sync. So we send the pull request and you just have to wait. And then this thing will give you the illusion that we're just actually processing, but all we will be doing is just waiting there for you. You probably won't see this in the near future, but this is kind of how we're handling But anyways, how does this architecture even helps with those problems I mentioned at the beginning, like the replication lag and the siloing and sharding? So replication lag, the way this can help us is by, so first we already created an app. It's actually you can go to GitHub, to the GitHub org and /Freno, which is that name there. And Freno is a thing that will know it will know the replication lag from a cluster. It's a Go application, and then you just tell it, Freno, tell me what's the replication lag right now, and it will tell you across your whole fleet what is the worst replication. So from all these, you have the master, and then you have a bunch of replicas. How bad it is right now. We'll tell you, okay, your worst replica is behind 1 second, or 2 seconds, or 5 seconds, or hours if things went really south. So the way we want to do this is by putting things in Kafka. We have a lot more control over how fast we can process data towards MySQL. And so you put in a bunch of data here. Then as soon as we notice there is replication lag, so let's say we notice, okay, there is an increase of 5 milliseconds, or 500 milliseconds instead. Have a second about to, and that's when like things start to become problematic. So we kind of stop all these consumers from consuming. And then really quickly the replicas are back, and then we keep consuming your stuff. We don't lose it, because in other cases what we will be doing is just, oh, we cannot process right now, let's just drop it. If you say you've tried to save an issue, then we will just drop it. Like, okay, we cannot, because there is replication lag right now, we don't want to process it, but we want your issue, we don't want to lose it. So what we do is, instead, we put it on Kafka. If there is replication lag, we stop these consumers from consuming. Replication lag catches up, and we're back. All the replicas are back to normal, and then we can restart consuming from the consumers. We can keep writing data to MySQL 1, and then we're back. And that, it's like we will be constantly asking Freno, these replicas, all these consumers can be constantly asking Freno, okay, what's the replication lag? And as soon as they notice replication lag is going up, they can't stop consuming. and then replication catches up, and then we don't have, because the problem is usually there is replication lag, and then people will keep blasting the database, and so that only makes the problem worse, because then replicas are even more behind. What we wish to have is more control. So we say we stop consuming stuff, or we find a way around it where we can kind of hold your stuff for a little bit, and then maybe later we will try to consume it when there is time, when replication is healthy again. And so that's how we help that replication lag problem. That's our expectation, that this could help us with that problem. And then the other thing that we want is siloing and charting. And it's not really like a direct solution. It's more like it just let us have more control over where the data goes to. And so that means that when we put stuff on Kafka, it's much more easy to decide because we have all these consumers and we can modify them more easily where to put that data. Do we want to put it in the MySQL host, or do we want to change? It's just a matter of control of where we want to put data, rather than just directly talking to MySQL. Those are the two problems that we're trying to fix. I think the main one is actually replication lag, but for us it's also important siloing people, and that's kind of our long-term picture. GitHub, so that's part of the thing we're trying to solve. So what has been the progress so far with this experiment? We enabled this thing for issue create and issue update and issue delete. Then we kind of, the way that these problems, they have a technical nature, but at this, I realized as a kind of an engineer at GitHub that, yeah, the technical problem is hard to solve, but not as hard as the human problem behind it. And the human problem behind it is actually convincing people to use this, because they're gaining nothing right away. You have to tell people, you know what? Now you're not using Active Record, you're using this stuff that is just gonna be a hell to use. And yeah, you cannot have the nice things that Active Record gives you. And they are asking, cool, but what am I getting? And you're like, nothing, really. You're not getting anything. It's actually just because we have to do this, because otherwise we cannot grow as much as we want long term. And so that's the difficulty. The difficulty is convincing people to use them and providing them with the right SDKs, the right documentation, kind of educating them into, okay, the actual nature of the system we have, which is actually, we are actually a eventually consistent system. Just because we have replication lag, it's like, yeah, eventually your data will show up there. It's just we're not being explicit about it. The system actually makes it very explicit. So a lot of it is politics, essentially. Just trying to talk to people and showing them and like, yeah, you will have to use this. Don't hate me for it, but it's a good thing at the end for the company, right? We also have some, of course, UI design changes, challenges that we will see. This is one of those changes that if this works out, then this is one of the potential changes that you will see. And yeah, it's also like talking to the product, like, okay, this is going to change. So let's figure out a way to make it work for all of us. And then there is also the API. That's an important part. Like the API is also going to change, and that's going to change the. It's kind of, there is this potentially backwards breaking change, which we don't want to do, because as soon as you tell people, oh, this change is backwards incompatible, everyone just like, oh no, don't. So we want to find a way to make it non-breaking change, not breaking backwards. You know what I mean? The point is, we want to phrase it in a way, or what you can do is you can essentially simulate an async system with a sync system, right? So it's just finding ways around it. One of the solutions, for example, is when you create an issue via the API, it's up to you. We could give you the possibility of waiting a longer timeout kind of time. You can give it a longer timeout if we can afford that. Otherwise, you can get a URL back to pull from that URL to see when your thing is ready, right? And that will also mean you have to wait until the replication happened, back and stuff. But none of that. I mean, nothing. If you're using the GitHub API, don't worry about it. It's not changing right now. You will get enough notice. Okay, so what we found so far. First, that is doable. That was the first question. Like, can we even do this? Is this a thing we can do? We staff shipped it, meaning that we shipped it for everyone at GitHub, and we started to see the graphs. Like, oh, someone is consuming stuff. That's pretty cool. But we saw some timeouts due to Ruby Kafka. Ruby Kafka is a library we're using to create consumers. I think it was done by Syntax. And they have when you have very low volume of messages coming into your queues, it will wait 2 seconds. Like if it tries to get data from there and there's nothing, it will just sleep 2 seconds. And there is literally a piece of code that says sleep. It's a line of code that says sleep 2 seconds. And we're like, oh, okay, what do we do about this? So we kind of tried to patch it, but it took a long time. So we created an internal fork, a whole mess. We're still working on that. And the other one is Kafka rebalancing during deploys. And this is an interesting bit. When you see this partitions thing, the magic of Kafka comes from the fact that here you will have 3 consumers, for example. And if one of those consumers dies, or you want to change it, so ownership of that partition changes to a different consumer, Kafka does rebalancing. And it's a bad thing. You don't want to have rebalance. You don't want to get rebalance because rebalancing means that the consumers that you have in a consumer group, which can be a few of them, they won't be able to consume for a bunch of seconds. And you can imagine that's a bad thing. So ideally, you don't want to have any kind of rebalancing happening. And what is going on right now is that we at GitHub, we're deploying all day long, which people just deploy like every 30 minutes or so. And so every time we deploy, there is partitioning in Kafka, and then we won't see a bunch of timeouts. People try to create a thing and then timeouts the request. And but those, honestly, I think those are like technical problems that are fixable. We will just have to tweak Kafka and Kubernetes a lot and all those things. It's kind of a pain, but yeah, eventually you can figure it out. The problem is, again, getting people to use this thing because they won't gain a lot right away. So a few of the problems that we found is protobots, for example, have a thing with how do you call this? The default values. So essentially, if there is a field that is null, like a string or whatever, it just puts a default value on it. So for example, string will just get an empty string. And for us, it's not like a convenient thing because sometimes people just delete something from it, from that field. That means we want to have that field be nil in the database. And then what do we do about that? So we have to like wrap the protobuf fields, some of those fields that we actually want them to be nil, wrap them in some Google protobuf library that we have, and then we have to build our own thing. It's kind of messy. So we have to do this pain. We don't want the entire company or the entire engineering team having to deal with that. So we have to provide wrappers and do the SDKs for that to solve that problem. The other problem is running these Kubernetes consumers. That's very painful as well. You have to understand how Kubernetes works, and you don't really want to do that. Also, if you don't really need to use Kubernetes, same with microservices, maybe. Just a suggestion. Anyways, and at the end, it just becomes a little bit of an unfamiliar environment for developers. I'm not saying that we can talk about that later. It's just, generally speaking, an unfamiliar environment for developers to have to run all these things, and you want to remove friction, essentially, because they are already kind of in their mindset like, oh God, why do I have to do this? As soon as they realize they have to run Kubernetes pods and stuff, they're like, oh no, not gonna do that. So you have to convince them in other ways. And so the current state of this experiment is we sat down again, okay, let's talk about this. What are we gonna do? We won't be able to convince anyone to use this thing. Let's iterate over it. And so we changed the architecture a little bit. So same thing, GitHub, the Rails app, events come in. The events are storing the same thing. By the way, this should say A, but I guess I didn't fix that. But now the difference is that we will have these generic logbook consumers. And these are they all look exactly the same. Remember that in the previous one, we will have a consumer for issue create, a consumer for issue update, a consumer for pull request create. And the owner of those consumers are the product owners, right? They will have to build those things themselves. In this case, we just built this. We are the ones who own this as an internal interfaces. We own those, the code of those consumers, and then they just look all the same, and they're really lightweight because all they're doing is actually request to an internal API that lives on GitHub. But we have the same control over the replication lag problem that I was mentioning at the beginning, right? So we have these internal APIs that are twerp. We're currently experimenting with twerp. We tried, what's the name of the Google one? gRPC, with really bad results. So we eventually moved to twerp internally. And so that's what we have been experimenting with. And now we're creating an API with twerp to solve the same problem. And it's the same kind of nature, right? Like you have these generic logbook consumers. You post an HTTP request with the twerp content back to MySQL, back to the Rails app, and then from the Rails app you save it in the database. And again, you have the control. The fifth step where you profit, that step, it's not clear here, is because it's the step where we're gonna put the final event, like, okay, the thing that was created so that search can use it or that machine learning can use it. We are still working on that, and we don't know exactly if we want to do it here in the consumer or we want to do it at the endpoint part. So I just didn't add it there because it's really, we have not defined where to do it. And what is next? The next thing is finish this twerp implementation. Actually, today in the afternoon, we got into review lab, which means for us it's just like an independent instance that we can put the code in and like try it, and that is seems to be working, so that's good. I hope. Hopefully my colleague may be seeing this and then he's telling me like it's actually not working. We're gonna staff ship that, put it available for everyone at GitHub, and then our next step will be actually putting this in production. So actually getting this to some amount of users and gather some actual performance metrics. Because right now, with all these timeouts, that we wanted to get the previous iteration to production, but with all those timeouts, you will see all those timeouts. That's just not good UX. So we said, okay, we will iterate on this, see if that solves the problem. Also, there is a little bit of this. These consumers most likely will be in Go, which is a little bit faster, has a better Go or Java, because Java also has a really good Kafka library, and so it's a lot faster. It's just doing this HTTP request, and yeah. So that's also in GitHub. Those are the two languages we're using the most: Ruby and Go, and a little bit of Java is also one of the languages we're trying to use. And then after we gathered some metrics and we said, okay, this is actually doable. We believe it's going to be like reasonable in terms of performance and so on. We're going to implement a second business object, perhaps pull requests, right? That's a good one, but internally we have a bunch of them. So we're trying to see what's the team that wants to roll with us into this next part of the experiment, because that's kind of the tricky part. We need to convince them and like, it's a good idea. Hopefully some teams actually will get value out of it right away. And so those are the ones we're going for first. Like, okay, I think this team could actually benefit very quickly from it. So we try to get them on board with the experiment. And the final step is GraphQL, but we don't want to talk about that. So yeah, that's the end of the talk. Thank you. Go ahead. One more line. Okay. start here. I think the first one.
Yeah. So within Kafka, the message. The message that you're sending doesn't have. You can choose which data you store. So it can be JSON, message tag, and auto security.
Yeah.
So one of the caveats that you mentioned is that vertical buffers are hard. They have some oddities, some weirdnesses. Why did you still choose to use the auto buffers instead of any other message formats?
Yeah, honestly, because we already had a library to to handle. There is another team at GitHub that already does this, uses Kafka with protobuffs for a different system, and it was just an easy win. Like, okay, let's go for this. Let's go. This just solves the problem. Later on, we realized, okay, it's actually more complex than we actually wanted it to be. It's definitely faster. It's pretty fast to like encode and decode those things. So that's kind of the advantage because it's a lot faster. But it has like kind of same defaults and all that. But those defaults are actually like biting us because it's a little bit harder to. But it's a good point. We could eventually. I mean, it's an experiment, so we can still change it. And, okay, go for something else.
No. Since you said in your next iteration, I would have expected that maybe the protocol should be there as well, since it's at the conclusions of the first iteration.
Right. Yeah. I think we will. The good thing is that we will, because they will just be handled HTTP requests at that point. At this point. Okay. At the point where from the consumers we're doing the request back to, I think we will be able to maybe handle that in the consumers, like getting that data there, and then they just do a plain HTTP request, and they can't forget about those details. But it's kind of on the way, still a discussion. But it's a good point. Yeah, maybe actually that gives me an idea. Maybe I should also look into that. Go ahead, Jerry.
So on the mainline application, when you are exporting the events into the Kafka log, how do you integrate it with Active Record and with the relevant application?
Oh, right now it's just. So in this one, for example, when we go back, this is a still active record. So in this iteration that we're currently doing, in the previous one, which is this one, these consumers actually load the entire environment from GitHub. So like they have access to active record. So it's a different process than this one. So it's not the same one that is serving your request, but it's a heavy consumer in the sense that it loads it has access to the Ruby, to the Rails environment. So it knows what active record is and all the gems essentially.
So in your Rails controller, you basically say Kafka clients those streams such and such don't write, and then you pass your payload, right?
Yeah, you from the controller you just push the message to Kafka, then you hold there until it comes back and tells you, okay, this is the ID of the issue you just created. We can discuss it later a little bit more in detail. Go ahead.
I hate to be that person, but I don't actually have a question. I just have good news, which is that we use almost exactly the same thing in Amsterdam. And I know solutions to free of your core technical problems.
Okay, that's fantastic. Let's talk about that then.
None of them include rewriting everything in Go, right?
Yes.
Cool. Anything else?
From what I've got, you're just monitoring the replication delay with Threader and essentially just waiting some time after writing to a master database with Tinco. You're not actually waiting for your write to arrive at all the replicas.
Yeah, essentially that's what we're doing.
So how does this solve the initial problem? Getting 404.
Oh, because once we notice that the replication once the replication is increasing, we kind of stop writing to the database so that the replication doesn't become worse. And these replicas have time to catch up. So if replication is 1 second behind, and you try to create a new object, then we wouldn't process that object right away. It's here, it's not lost, but these consumers are waiting until replication is back at zero. Replication lack is back at zero, and then we can continue processing those things. So by the time this is created, it could potentially happen again, right? Like, yes, okay, when you create it here, it's like at that very second, at that very millisecond, like replication went up. But I think the chances of that happening are much, much lower than what we currently have right now. So yes, I think in a way you're right. It could potentially happen. But the chances are, I mean, just like there is essentially no way to solve that problem. At least as I can think of it. But if you have a good solution, then maybe you can tell me about it. Go ahead.
How do you achieve the happy consumers? Are they like break tasks in your mono repo, or?
Yes, essentially. It just loads the same kind of like more like slightly different version of the Rails bootloader or something like that. So it's essentially that thing. That's how we have the. Yeah, it's a little bit heavy, and we probably, for example, the cool thing about this one is that the consumers are just doing HTTP requests, so we don't have to load the entire environment. But these things come with problems as well. So this seems like very motivating, but hopefully you won't have to do this. It's not precisely like the most beautiful thing, because now we will have to deal with what happens if all these processes here are at capacity, and these consumers are just blasting them. So it's things that you have to think about and find missions around. It's not that we have all the answers right away. It's just exploring and see what we find. Anything else? We're good? All right. Thank you.
I'm very happy that you shared with us how creating issues at GitHub creates issues at GitHub.
Absolutely.
Keep those talks coming because I really like them. And again, if there's something that sparks your interest, feel free to ask the organizer so I can fake like it's my request, or I can actually just shoot requests at speakers. And talk to us if you want to host next Amsterdam.rb, which will be in December 17th. And now have some drinks, eat some pizzas. Come on, talk to people that you don't know. Do it.
Do it.